Hello, I'm going to explain how to do calculations in Arduino and how to run commands and combine commands. But first I'm going to go through the code that I've got here, some of which you've seen before, some of which might be new for you, but I'll cover everything. First, in the setup, which is that function that runs only one time, just as you start up the Arduino. What we do is we tell the Arduino that port number 11, which on the Arduino is the digital port that has this LED attached to it, that is an output, that I want to write data to it, and I don't want to use this port to read data.
You have to choose?
I have to, well, I have to choose.
Okay.
One of the two is the default, but I'm never sure which one, so I always explicitly mentions whether something is an output or an input to avoid mistakes. And I've also tell the Arduino that I want to communicate over the serial port, which we've seen previously, and I want to do it at a speed of 9600 baud.
Baud
is a way of measuring speed. Then in the loop, which is the function that is called after the setup is done and continuously called, what I do is I tell firstly I put a comment here. And a comment is something that starts with two of these forward slashes.
Okay.
And you can put anything you want there. It is not executed. So usually you use it to put some notes or to describe what your program is doing. But then, after the comment, I say digital write 11, which means that I'm going to write current to port number 11.
Mm-hmm.
And I'm going to put high current, as in the voltage that goes there is going to be high, which basically means 5 volt in this case.
Okay.
So port 11 that has this LED to it is now going to be on. So the LED is going to go on. Then I'm going to wait for 2000 milliseconds.
Yes.
While I'm waiting, this port is still on, because it's going to stay on until we specify otherwise.
Okay.
Which we're going to do here, because now at port 11 we're going to put low, which means that there's not going to be any current left. And then we're going to wait another 500 milliseconds.
Okay.
Then the loop starts again, and we once again have a high current, and the LED is going to be on. Now, if you have a look at the Arduino, it's currently running this code, but I'll put it there. So we're done uploading and it works. And what you see, it's on for 2000 milliseconds and then off for 500 milliseconds. So that seems to be working. I'm going to do a little bit of an experiment. What I'm going to do is I'm going to do a serial print line, which we've seen before.
Yes.
And what I'm going to do is I'm going to put a calculation here.
Okay.
So I'm going to put 1000, which if we run it, it will just say 1000. Let's do that. Remove this thing. There we go. Put serial print, and every 2.5 seconds it's running 1000. So that works. That's what we were expecting. But now what I'm going to do is, instead of just having 1000, I'm going to subtract 500 from it and divide it by 2, hoping that it will follow the same logic that we've had during our mathematics class in secondary school, that division is going before subtraction.
Yes.
So that what I hope that it will do is it will divide 500 by 2, 250, and subtract this 250 from 1000, and then print it to the serial port.
Cool.
Let's see what that is, what happens. And yes, it is. So, conclusion, I can put a calculation where I could put a value. And it will
Yes.
first do the calculation, convert it into a value, and we'll send that, in this case, to the serial print.
Okay. Cool.
I'll do another experiment,
Mm-hmm.
which is this. In this serial print line, I'm going to put another command. I'm going to say analog read 0. What does this do? Well, if you have a look at this, the blue wire is attached to the analog port 0. And what that means is that that is one of these ports that can measure electricity.
Yes.
And I'm going to read that in an analog way. And with this pot meter, I can very easily show you what that does by just running the code in the serial monitor. And it's currently saying 185. What does that mean? Well, this pot meter, potential meter, is currently set somewhere halfway. And I'm going to close it all the way. Well, actually I've opened it all the way. And what you see is that there is a number there, 1023, which is the maximum number that can be read by the analog port.
Okay.
If I close it all the way, it becomes 0.
Yes.
And if I put it somewhere in between, oh, that was a good guess, 560 is somewhere halfway. I can get a very accurate reading of the precision of this potential meter.
Okay.
Which is interesting because we can also do sums with this.
Yes, but can you explain beforehand how it works when you put a command inside another command?
Okay. This analog read command returns a number, which means that every time I use this command, it becomes a value.
Okay.
And I can calculate with this value.
So where it says analog read
0,
when it's executed, it becomes 1023 or 0
or something in between.
Yeah.
Yes. And I can put a different number here. This is port 0, so I'm now reading
the blue
wire. If I put it on the first one, if I make this a 1, it goes to the pin next to it.
Okay.
Yeah.
Okay.
But let's do a calculation, because let's say we want to divide this by 2. So now, what's happened? If it's completely closed,
yes,
it's going to remain a 0.
0 divided by 2 is 0.
Is 0. If it's completely open,
1023 divided by 2
is a bit more complicated. Could be 511, could be 512.
Okay.
Let's find out. Going to run it. It's somewhere in between. Let's open it. 511.
And why doesn't it say 511.5? Because that's actually the half of the.
That would be a
the
more
correct
accurate.
value,
That
yes.
would be a more accurate value. But this analog read thing only ever returns a whole value.
Yes.
And in Arduino, if something is a whole value and you do calculations with it, it stays a whole value.
Okay.
And that's what's happened here. Now let's do something interesting, because now we've just serial printed this command. We can also use this calculation in a more interesting sort of way. Because instead of having a delay of 2000, what I could do is I could just say analog read 0, well, maybe times 2. So now the delay is going to be anywhere between 0 and 2048 or 46.
Yes.
Yeah,
Cool.
0 is maybe a little bit short, so maybe add 200 to it.
Okay.
So that there's always a minimum of 200.
Yes.
And we can do the same thing with the delay for the having the thing on. Let's say analog read 0 and divide it by 2 and maybe add 100 to it.
Cool.
So now we've made this delay dependent on the position of the potentiometer.
Show me.
Okay, there we go. I'm running it. And we notice that the LED is flashing very slowly. Now let's close the potentiometer. It's flashing very quickly. Open it, put it somewhere in between. It is somewhere in between.
Okay. And if you have it fully closed?
If it's completely closed, it's going to be, it's going to pulse for 100 milliseconds.
Yes.
And be on for 200 milliseconds.
Cool.
Yep.